Have you ever wondered where the universe ends? What if I told you it might be in a black hole? Yes, black holes. Those enigmatic phenomena that have captured the human imagination and have been the stuff of science fiction. But they're not just the stuff of Hollywood. Black holes are real, and they are out there in the cosmos. Imagine a region of space so dense, so heavy, that nothing, not even light, escapes its gravitational pull. That's a black hole for you. They are formed when massive stars, much larger than our sun, exhaust their nuclear fuel and collapse under their own gravity. Black holes come in different sizes too. There are stellar black holes born from the collapse of massive stars. Then there are the theoretical intermediate black holes and the gargantuan supermassive black holes that lurk at the centers of galaxies. Now you might be wondering, how does such a massive and mysterious entity form? Our journey begins with the birth of a star, much like our own sun, but far more massive. Picture a vast swirling cloud of gas and dust suspended in the depths of space. This is a stellar nursery where stars are born. Over time, gravity, the cosmic architect, begins to pull this cloud together. As it collapses under its own weight, a dense hot core forms. This is the heart of our future star. Gravity continues its relentless pull, drawing more material into this core. As it grows, the pressure and temperature at the heart of this cloud increase dramatically. The conditions are now ripe for a process known as nuclear fusion. In the searing heat and pressure of the core, hydrogen atoms begin to merge, forming helium and releasing a tremendous amount of energy. This is the spark that ignites the birth of a new star. These newborn stars are much larger than our sun. They burn brightly, illuminating the cosmos with their light. But this light show is fleeting. In cosmic terms, these massive stars live fast and die young. Their intense energy production means they burn through their nuclear fuel quickly. So we have a star, but how does it transform into a black hole? Stay tuned as we continue our cosmic journey from the cradle of a star to the grave of a black hole. A star lives a spectacular life, filled with nuclear reactions and a constant battle against gravity. At the heart of this celestial drama is nuclear fusion, the process that powers a star's radiant glow and keeps it from collapsing under its own weight. Nuclear fusion is the process where atoms combine to form larger atoms, releasing an extraordinary amount of energy. In stars, it's primarily hydrogen atoms fusing to form helium. This fusion happens in the core of the star, where temperatures are unimaginably high and the pressure is immense. This fiery process releases energy in the form of light and heat, creating the magnificent glow we see in the night sky. But nuclear fusion doesn't just produce light and heat, it also creates an outward pressure. This pressure counteracts the inward pull of gravity, maintaining a delicate balance that keeps the star stable. It's a cosmic dance, a tug of war between the forces of gravity and fusion. However, nothing lasts forever, and this is especially true for a star. Eventually, after millions or even billions of years, the star exhausts its hydrogen fuel. The nuclear fusion slows down, and gravity begins to win the tug of war. The star's core contracts under the relentless pull of gravity, causing the outer layers to expand. The star has now entered the red giant phase of its life. But the drama doesn't end there. Depending on the star's mass, its final act could be just as spectacular as its life. The contracting core may ignite a new round of nuclear reactions, leading to a supernova explosion or the creation of a dense stellar remnant like a white dwarf, a neutron star, or even a black hole. Once the fuel runs out, the star's life takes a dramatic turn, leading to a spectacular event. The death of a star is not an end, but a transformation, a cosmic spectacle that gives birth to new elements, new stars, and sometimes the most mysterious objects in the universe, black holes. Imagine the most incredible fireworks display you've ever seen. Now multiply that by 1,000,000. That's a supernova. This dazzling spectacle marks the final act of a massive star's life, a grand farewell that outshines entire galaxies. But how does it happen? Let's dig in. A star, throughout its life, is a delicate balance between the inward pull of gravity and the outward push of energy from nuclear fusion. Once the star exhausts its nuclear fuel, this equilibrium is lost. The core contracts under its own gravity, and the star starts to collapse. In stars of sufficient mass, this contraction triggers a catastrophic explosion, a supernova. In a brief moment, the star releases as much energy as our sun will over its entire 10 billion year lifespan. This force is so powerful that it blasts the outer layers of the star into space at speeds of thousands of kilometers per second, creating a brilliant light show. But the supernova isn't the end of the story. It leaves behind a highly dense core, a remnant of the star's heart. This core, depending on its mass, can have one of two fates. Either it becomes a neutron star, an incredibly dense object made mostly of neutrons, or if the core's mass is large enough, it collapses further, paving the way for a black hole. After the supernova, all that's left is a dense core, but under the right conditions, this is where the magic happens. From the remains of a massive star under immense gravity, a black hole is born. Let's dive into this cosmic phenomenon, the birth of a black hole, and unravel the secrets it holds. When a star, much larger than our Sun, exhausts its nuclear fuel, it no longer has the energy to fight against the relentless pull of its own gravity. The core starts to contract, leading to a dramatic supernova explosion where the outer layers are violently ejected into space. What remains is an incredibly dense core. Now, if this core has a mass above a certain critical value, roughly 3 times the mass of the Sun, a fascinating event takes place. Gravity triumphs over all other forces and the core collapses further, shrinking to an infinitesimally small point known as a singularity. This singularity, a point of infinite density and zero volume, is cloaked by a boundary known as the event horizon. The event horizon marks the point of no return. Beyond this boundary, the gravitational pull is so strong that nothing, not even light, can escape. Hence the term black hole. It's not a hole in space, but an extremely dense concentration of matter. Black holes can be of different types. Stellar black holes, born from the collapse of massive stars, have masses ranging from about 3 to 10 times that of our Sun. Then there are the hypothetical intermediate black holes, whose existence is yet to be confirmed. And finally, we have the supermassive black holes, boasting masses millions or even billions of times that of the Sun, residing at the centers of most galaxies, including our own Milky Way. The size of a black hole, however, isn't determined by its volume, but by the size of its event horizon. Despite their enormous masses, black holes are usually quite compact. Their physical size is determined by their mass and is often much smaller than the star from which they were born. And thus, from the remnants of a star, a black hole emerges, completing a cosmic cycle of birth, death, and rebirth. So, we have journeyed from the birth of a star to the formation of a black hole. We began with a cloud of gas and dust drawn together by gravity to ignite a massive star much larger than our Sun. Inside this star, nuclear fusion converted hydrogen into helium, releasing energy and creating a delicate balance between outward pressure and gravity. But when the star exhausted its fuel, this balance was lost. The core contracted, and in stars of sufficient mass, this led to a supernova, casting off the outer layers and leaving behind a dense core. If this core's mass exceeded 3 times that of the Sun, an unstoppable gravitational collapse formed a black hole. Stellar, intermediate, and supermassive, these black holes are not voids, but incredibly dense concentrations of matter. In the grand tapestry of the cosmos, black holes are a testament to the life cycle of stars and the incredible forces at play in our universe.